Joe Cassady is that one guy every team should at least have one of. Even-tempered, dedicated, goal-oriented, and an all-round good guy to work with. A great colleague with an immense knowledge of his field. No wonder Aerojet Rocketdyne entrusted him with space for their DC office. A sound choice as far as I'm concerned. Joe is a Purdue man, just like Neil Armstrong, another even-tempered, goal-oriented guy. I wonder, if we're thinking about Purdue and what they produced in astronauts and other great engineers, if it's in the water of Indiana or in the selection of the Purdue students, as there are really a great number of space champions stemming from Purdue. Joe came to Explore Mars fairly early in our existence, and as you can imagine, he's a great addition to our group. Joe brings so much rocket know-how to our team that I can hardly imagine us all getting to Mars without Joe's insight. Hence, Joe's leading role for the last Humans to Mars report, which he will talk about as soon as I hand over the microphone to him. Now, Brett, I am going to introduce you as well, because you're both going to be here on the podium. Brett Drake, another great guy to work with, which I had the pleasure to work with on the Humans to Mars report. And if you look at Brett's accomplishments up till now, he is a very logical choice to be part of that group. Because Brett has been going at Mars mission architecture for a long time, about 30 years, 26 of which at NASA. At NASA, he helped the design and analysis of human exploration mission approaches beyond low Earth orbit, including missions to Mars. Back in 1998, he was editor of the reference missions 3.0, which of course focused on how to get humans to the surface of Mars. Being part of the Mars Architecture Steering Group for years, that's what Brett was as well, supporting other key strategic planning efforts, notably being part of the experts behind the Augustine Committee report. He currently works for the Aerospace Corporation, leading the human space architecture studies. Personally, like I said, I had the honor of working with Brad on the last version of the Humans to Mars report. I can only say that it is not just his in-depth knowledge of Mars architecture which makes him a great colleague, but also his keen sense of humor. It is with great pleasure that I also call to this floor Brett Drake. Gentlemen.
Thank you, Artemis. So we called an audible. I think I'm just going to talk since we want to try to keep on schedule, and we only have 20 minutes, but Artemis is absolutely right. Brett was the co-chair for the report and deserves a lot of credit. Otherwise, if we had more time, we'd both come up here and have a more relaxed conversation with you all. But I just wanted to share what you'll see when you go into your folders and take the report out. You can see the cover artwork here. It's been a very exciting year. We started this report last year, and our intent was to do it on an annual basis and to keep it up to date, because one of the things we realize is it's extremely important for us to keep the public, all of the stakeholders aware of the progress that is being made. And it's even more crucial as we approach this election year that is the case. So let's go right into the year in review and what we'll show you in the report. So, oh, I forgot to pick up, that's right. I'm supposed to do this myself. There we go. So, the first thing that we cover in the report is the science aspect, and it has been an amazing year. I'm sure all of you are familiar. In fact, over the past 5 years, all of the discoveries that we're learning about Mars with the robotic craft that we have up there now, both surface and in orbit around Mars, and I'm sure you're all aware that we've added to that this year with MAVEN and its studies of the atmosphere and the interaction between the sun and Mars atmosphere, and some of those very exciting things are included in the report this year. We know that Mars once now, in contrast to when we first started the reconnaissance of Mars all those many years ago in the 70s, Our first blush, when we looked at it, it looked like a very arid, dead world. We're learning more and more that it was not always that way, that in fact there once was a habitable environment capable of supporting life. And the more we've been there and the more we're beginning to learn about it, we now know that there's actually organic molecules present now on the surface of Mars, even though the surface environment probably can't support life. But we're also seeing that there are seasonal cycles. We've known about the polar caps, the carbon dioxide cycle. We now see things like gaseous geysers. We've seen methane plumes. And then this year, and in the past year, the discovery of the recurring slope lineae, those fantastic streaky things that show up and disappear on a seasonal basis, which are probably presence of liquid water at the surface. So it's exciting. It's a really, really encouraging time for us because we know that those things are likely going to be indicators of the potential for life. In the future, looking out 5 years, what do we see on the horizon? Well, there's a whole just exciting group of missions that are planned. We chose to focus here on the Mars 2020 rover because it's a particularly exciting one. It will combine many of the elements that are there now with Curiosity, and it includes some additional features that are going to be really critical to the future human exploration of Mars, including an experiment that's going to go along called MOXIE. MOXIE is going to show that we can actually use resources on Mars, and that's the other reason that it's exciting for us to find that we've got things like water present on Mars. And of course, the atmosphere of Mars gives us a resource that we can use. So MOXIE will look at actually making oxygen from the atmosphere of Mars on a small scale, but it's a precursor mission that will allow us to extrapolate what we can do in the future to support human missions on Mars. And that's going to be really critical to a sustained presence on Mars. And that's what we're really all about. We're going to Mars and we're going to stay. We're not going to go and plant a flag and come home. The other thing the rover is going to do is it's going to cache materials. One of the key things that we need to do before we send humans to Mars is we need to understand a little bit more about what's going on the surface of Mars from in terms of planetary protection, as well as the scientific discoveries that we could make back here in Earth laboratories if we had a sample in an Earth laboratory. So we hope to be able to put those all together in a place that we can send a later mission with a small rocket that can bring them back to orbit, and then we can return them to Earth. So it's going to be really, really exciting. In addition to that, there's a number of other missions that are on the books or under study now, including missions to enhance our ability to do the reconnaissance of the Martian system, including the moons, as well as do that potential sample return. So we're looking at completing a round trip to Mars, in advance of actually sending the humans to Mars using a lot of the same technologies that we would use, as well as being able to do something like in fact, let me go to the next chart. We're going to use these robotic missions as precursors, as I said. And in doing that, we're not only accomplishing science on the science missions, but we're also preparing the way for the eventual human missions. And that's another, I think, really exciting aspect of what we see happening now. We're combining the human aspects and the preparation for going to Mars with humans and the robotic activities and the science missions, and we're almost working together just without any, interface. It's been very exciting. Some of the things that have happened, the first Mars exploration landing zone workshop was held last year in Houston. So we're actually now focused on where should we go? What's going to be the right place to go? Artemis suggested one there earlier, and she was at the workshop. But we're beginning to see the focus on those kinds of things. We had another workshop, we've had 3 now, here in Washington on affording Mars. We're looking at architectures, we're looking at ways to do this that we can do within the budgets that we think we're going to be able to have going forward over the next 20 years, and to do it in a sustainable fashion, as I said. And we're also planning for these missions that will go before the humans so that we can fill those strategic knowledge gaps. And it gives us the opportunity, as I said earlier, to test some of the key technologies such as solar electric propulsion and new entry, descent, and landing technologies that are going to get us to the point where we can land the heavier payloads we're going to need for humans. Right now we can put about 1 metric ton down on the surface of Mars. We need to be able to put at least 20 metric tons down in blocks to support human missions. So we've got a couple of key recommendations there that you can see. One is this next generation orbiter. That's an opportunity in the early 2020s. It can replace the telecom relay capability we have now on some things that are getting a little bit old, as well as enhance our ability to look for some of those resources that we'd like to be able to take advantage of for the human missions. And then also completing a complete round trip to Mars using something like solar electric propulsion would be something we could do with those robotic missions. In terms of the architecture, that's been an ongoing activity over the past several years. There's a number of different architectures out there. NASA's working on something that they call the Evolvable Mars campaign. But it's beginning to come together, and we see common elements that we recognize as necessary to do this. In addition to that, we've obviously completed some really critical research this past year on the ISS. We're continuing to do that. It's providing data that's going to be very valuable for the human aspect. And we're preparing to go out to an area around the moon which will give us the ability to simulate the deep space environment that we'll see going to Mars, because that transit of several, 6 to 8 months time is much longer than we've had humans out in deep space. So we need to go there and do progressively longer missions and test out the systems that are going to take the humans there to keep them alive and make sure there's no impact of things like the radiation environment on those systems. We're well underway with SLS and Orion, making great progress there, test flights on EFT-1, testing hardware, building hardware, so that's a very exciting thing. And we're beginning to see some initial studies on deep space habitats, and we've begun to work on the key technologies like solar electric propulsion that'll deliver the cargo. And that's really the key to this, is we're going to split up the crew and the cargo, pre-position a lot of the cargo, take it out there with very effective solar electric propulsion, and then we can send the crew much faster because they don't have to take everything with them on the same ship that they go on. One study that was done was, we called it a case study or an existence proof, was done by JPL last year. It was very interesting because what they did is they said, let's see what we could do within the budget constraints that we believe we're going to have. And this we called an existence proof, because there's a lot of people who say you can never do this Mars thing with the current human spaceflight budgets. And what you see in the report, and you'll see all the details in this graph, is the proof that that's not true. So we know now from the JPL study that it is possible to do it. We're now beginning to look at slight variance on that study and how we can improve upon it a little bit. But it was a really watershed moment to see that, we can go now confidently to people on Capitol Hill and say, with a NASA existing budget adjusted for inflation, this is possible to do. Now, think about what we can do if we have just a little bit more budget. We can be even more ambitious and still do it in the time frame that's of interest in the 2030s. These are the key elements. These are the things that we've found in doing this work that are going to be necessary. I mentioned SLS and Orion. We're beginning to work on the deep space habitat. This will be the transit ship that will take the astronauts to Mars. The solar electric propulsion work is now underway. We're working on those technologies. It's actually scaling up something we already do for commercial communication satellites. So it's not a new technology. It's not something that we need breakthrough physics for. A key area is entry, descent, and landing, as well as Mars ascent. And that's something we're working on. We're beginning to get to the point now where we're learning a lot about that. So we're making those initial steps, and you'll hear more about that at the conference. Mars surface systems, it's going to be a key element. And as I say, we're learning a lot from the robotic missions that's going to help inform that. And then the development of in situ resource utilization with things like MOXIE flying on Mars 2020. So we're going to move out into this area around the moon, cislunar space, the proving ground. We're going to do some missions out at Mars with the robotic missions that I mentioned. This whole time frame of the 2020s is going to be our shakedown cruise. It's the proving ground. We're already starting. We're starting with things like Scott Kelly's mission on the ISS, the year-long mission. So there's a whole lot of things that we're pulling together. We've got the human element. We've got the strategic knowledge gaps that we're starting to retire, getting the risk retired. We're going to get ourselves ready in the 2020s. By the end of the 2020s, we're going to be ready to put that first human mission together, and we're going to go out to Mars in the 2030s. Right now, we don't see any showstoppers, and that's the key. I think there's a lot of information out there that people have that say, you know, radiation's a problem or microgravity's a problem. That's why we're doing things like the Scott Kelly mission, and the current evaluation is it could be done. There isn't a showstopper there. And finally, we can't leave any report like this, cannot leave out policy, because there's no way we're going to do this without a long-term support of key stakeholders who provide the budget. And so we've looked at a number of things in the report you'll see, including the fact that we're making good progress. We've built up a lot of momentum. I think all of you who've been at this conference for the last several years have seen that. I was talking to some folks this morning, and they were remarking on that very thing. We don't want to lose that momentum. We've got to keep the momentum. We've got to drive on. Charlie Bolden has said, we are closer now to going to Mars than we've ever been in his career. I think that's true in my career. I feel that way. We can't lose the momentum. We got to keep going. We've got a lot of good ideas for how to reduce the timeline, how to keep the funding within the budget. And we got to keep talking about that. We're getting better at it. We got to share that. We got to get that out to the right people so they understand that. We've got to take advantage of things like The Martian. I'm sure everybody here probably saw The Martian. It's a phenomenon that, read the book. And I can tell you, when I read the book, I couldn't put it down. I lost a lot of sleep in a couple of days when I was on a business trip because I just read the book all night. But taking advantage of that, capture the public's imagination. We can build on that. There's a lot of good tie-ins there. And the other thing we found when we do the polls that Chris mentioned earlier and things like that is you've got to put the space budget in context. A lot of people have a really distorted view of how much money we spend on this. And when we put it in context for them, they're just amazed. For less than half of a penny of the federal budget, NASA gives you the universe. I mean, how can you argue with that? Thank you.